Students, now we will do the sixth problem of exercise 5.1, where we have to find all the points of discontinuity of the function f of x, which is equal to 2x plus 3 when x is less than or equal to 2, or it is equal to 2x minus 3 when x is greater than 2. First, I will explain the graphical representation of this function. Then it will be easy for you to understand how to go about the discontinuity part of it. Okay. So, f of x is equal to 2x plus 3 when x is less than or equal to 2. You can see that the graph of y is equal to 2x plus 3 or f of x is equal to 2x plus 3 is of this kind, and the function takes this form. Okay, the form is a straight line until x is equal to 2, which is represented by a solid circle or a thick circle. So this point is 2, 7. So for all values of x less than or equal to 2, the graph of the function f of x is a straight line as shown in this diagram. Okay. Next, what happens when x is greater than 2? That is, after 2, it becomes f of x is equal to 2x minus 3. So this is a different straight line. So it is y is equal to 2x minus 3, and this is the graphical representation of it. I am showing it in red. Okay, so after x is equal to 2, it takes this form of the straight line. So it is very obvious that at the point x is equal to 2, there is a discontinuity. Until x is equal to 2, it's a straight line, after which it suddenly breaks, and then from the point where x is greater than 2, it will start taking this form. So there is a break in the graph. You cannot draw this graph continuously without lifting your pen. Therefore, this function will be discontinuous at x is equal to 2. So at all other points before x is equal to 2, you can see that the function is a straight line, which is a polynomial function, so it will be continuous everywhere. Similarly, after x is equal to 2, that is for all values of x greater than 2, again it is a straight line, so it will be continuous everywhere. But this we will be showing mathematically by taking 3 cases. Now, what are the 3 cases? We will be assuming one value x is equal to c, where this c is less than 2, and we will check for continuity of the function for x is equal to c less than 2. So that is the first step, where we will be taking a value of c which is less than 2, where the graph will be this kind of a straight line. Alright. Next, the second case, we will be considering x is equal to c, which is a value greater than 2, and then we will discuss about the continuity of the point x is equal to c, which is greater than 2. So that is the second part. The third part is to check if the function is continuous at x is equal to 2. So at x is equal to 2, we evaluate the limit of the function as x tends to 2, and then we will find out the value of the function at x is equal to 2 and check if the function is continuous at x is equal to 2. So there are 3 parts: c, where c is less than 2, x is equal to c, where c is greater than 2, and x equal to 2. So these are the 3 points where we are going to discuss about the continuity of this function. Okay, so the first part, as I told you, consider x is equal to c, where this c is less than 2. Okay, so c is less than 2. Say for example, you can consider a value like x is equal to 1.5. Okay, 1.5. Now let us find out what will be the left hand limit of this function. Okay, so what is the left hand limit? Left hand limit is limit as x tends to c minus, where c is a number which is less than 2. In our case, we will assume an example of 1.5. So x tends to c minus means it is a number in our example which is very close to 1.5 but to the left of 1.5. Okay, when it is to the left of 1.5, we can say that definitely it will be less than 2, therefore the function will now take the form 2x plus 3. So the left hand limit is limit x tends to c minus f of x. Now since c is definitely less than 2, f of x will be replaced by 2x plus 3. So this is equal to limit x tends to c minus 2x plus 3. Okay, now what does this x tends to c minus imply? It means x takes a value like c minus h where h tends to 0. So this step now becomes limit h tends to 0. Now x will be replaced by c minus h. So it is 2 into c minus h plus 3. Now what are we going to do? We will substitute the value h is equal to 0 in this. So we will be getting 2c plus 3. So this is equal to 2c plus 3, which is nothing but the left hand limit of the function. For x is equal to c less than 2. So that is the left hand limit. Next we will find out the right hand limit. Now for the right hand limit, what happens? It is limit x tends to c plus, okay, f of x. Okay, here how is c taken? X is equal to c, which is again less than 2, but we will be evaluating the right hand limit, which is x tends to c plus. C value is still less than 2. Say for example the same 1.5. So x tends to c plus will be a value very close to 1.5 but to the right of 1.5. Like for example 1.500001, which is definitely greater than 1.5 but to the right of 1.5. Still the value of c will be less than 2. Hence the function will take the form 2x plus 3. So this is equal to limit x tends to c plus 2x plus 3. So what does this c plus mean? C plus means x is equal to c plus h as h tends to 0. Therefore the RHL is now limit h tends to 0. In place of x, we will now be putting c plus x. So 2 into c plus h plus 3. So this is equal to 2c plus 3. Therefore, the right hand limit is equal to 2c plus 3. Okay, so you can see that the left hand limit and the right hand limit both are the same. Let us also find the value of the function at the point x is equal to c, where c is a value less than 2. Now f of c, where c is less than 2, is f of x is equal to 2x plus 3 for c less than 2. So which is equal to 2c plus 3. Therefore f of c will be equal to 2c plus 3. So again we can see that the value of the function at c is also equal to 2c plus 3. So we have the left hand limit equal to 2c plus 3, the right hand limit equal to 2c plus 3, and also the value of the function at the point x is equal to c is also equal to 2c plus 3. Therefore the function is continuous for all values of x is equal to c, which is less than 2. Okay, so that is what we have shown in this graph also. So for all values of x less than 2, the function is continuous, which is represented as a straight line in the graph. Okay, so this is for x is equal to c less than 2. We should do the same step again for x is equal to c greater than 2, and let's see how we are going to do that. Students, you can also note one thing about the graph of the function f of x. F of x is equal to 2x plus 3 and f of x is equal to 2x minus 3. What can you say about these set of straight lines that we have drawn? So do they represent any kind of relationship, a straight line relationship? Yeah, because y is equal to 2x plus 3 and y is equal to 2x minus 3 in two different intervals. You can see that the constant alone is varying. So in one it is 2x plus 3 and in the other it is 2x minus 3. Since the constant alone varies, you can see also in the graph that the two set of lines are representation of parallel lines. See, these are some things which you should look and observe in any given problem and understand more about it. Okay, so graphical representation is a better visual representation of continuity through which you can understand continuity better than even the mathematical way of understanding continuity. Okay, now let's go back to consider x is equal to c greater than 2. Okay, so now we will be doing x is equal to c greater than 2. Again, we will be evaluating the left hand limit. So what is the left hand limit? Limit x tends to left hand means c minus f of x. So this number is greater than 2. Say for example, let us assume a number like 2.5. Okay. So when x is equal to 2.5, a number very close to 2.5 but to the left of 2.5, say for example, it could be 2.4999. Okay. This 2.4999 is still greater than 2. Therefore, f of x will now take the form 2x minus 3. So, this is equal to limit x tends to c minus 2x minus 3. Okay. Because this c is still greater than 2. Say for example, we took 2.5 and to the left of 2.5 like 2.4999 which is less than 2.5 but it is also greater than 2. Therefore, the function f of x will take the form 2x minus 3. You have to be very careful while you write steps of this kind. While extracting what the function could be, when a list of varying functions are given in different intervals, you have to be very careful in listing the function in the limit. Okay. So, it is limit x tends to c minus 2x minus 3. So, now we are familiar with what is x tends to c minus. It is x is equal to c minus h as h tends to 0. Okay, so this is equal to limit h tends to 0. In place of x, we will now be writing c minus h. So, it is 2 into c minus h minus 3. Now, when h tends to 0, what will happen? The function will take the form 2c minus 3 or the value of the function will now be, the limit of the function is nothing but 2c minus 3. So, this is equal to 2c minus 3. Therefore, LHL is equal to 2c minus 3. Okay. Now, let us find out the RHL. What is the RHL? It is limit RHL is to the right of c. So, it will be x tends to c plus f of x. Again, in our example, we took 2.5, right? So, c plus will be some number like 2.50001, which is indeed greater than 2. Therefore, f of x will take the value 2x minus 3. So, this is equal to limit x tends to c plus 2x minus 3. Okay. So, again, what is x is equal to x tends to c plus means? So, it means x is equal to c plus h as h tends to 0. So, this is equal to limit, you will change the limit to h tends to 0 and in place of x, we will be writing c plus h. So, it is 2 into c plus h minus 3. Okay. So, now h tends to 0, limit 2 into c plus h minus 3 is nothing but 2c minus 3. Therefore, what is RHL? RHL is 2c minus 3. Okay. So, we have found the values of LHL and RHL. We will also find f of c where c is greater than 0. So, f of c here c is greater than 2. Okay. So, f of c is equal to greater than 2. It will take 2c minus 3. So, this is the value of the function at the point x is equal to c where c is greater than 2. So, we can see that the LHL is 2c minus 3, the RHL is 2c minus 3 and the value of the function at the point C is also equal to 2c minus 3, which explains that the function is continuous for all values of x greater than 2. Okay, so take any value of C which is greater than 2, you will find that the function is continuous. Alright, now comes our critical part, the third one. Consider x is equal to 2. Okay, so we should now get the values of LHL and RHL which are different, which means the limit itself will not exist, which will further imply that the function will not be continuous at x is equal to 2. So now how do we do that mathematically? Consider x is equal to 2. So again we will be finding out the LHL, right? So LHL, what is the LHL? Limit x tends to 2 minus, in this case we can directly write it as 2 minus f of x. 2 minus is a value less than 2. So if it is less than 2, the function will take the form 2x plus 3. Therefore we will here write this is equal to limit x tends to 2 minus 2x plus 3. Okay, so in most of the textbooks you can find that 2 is just substituted even in case of 2 minus, because every time doing x is equal to 2 plus h as h tends to 0 will make the problem too lengthy. But then for you to understand and appreciate what is limit and what is the left hand limit and right hand limit, it is always good to follow a longer procedure which will give you more clarity. Okay, so it is x tends to 2 minus, so again we have x is equal to 2 minus h as h tends to 0. So this is equal to limit h tends to 0. So now in place of h you will be substituting what? 2 minus h. So 2 into 2 minus h plus 3. Okay, so now when you substitute h is equal to 0 over here, you will be getting 2 into 2 plus 3. Okay, so this is 2 into 2 plus 3 which is equal to 7. Therefore the LHL is equal to 7. Okay, this is what I have shown as a solid circle. Okay, at x is equal to c, the value is equal to 7. So the left hand limit is equal to 7. Now we will do the right hand limit of the function at x is equal to 2. So we should now do the right hand limit at x is equal to 2. Okay, so this will be equal to limit x tends to 2 plus, because it is the right hand limit. Now 2 plus is a number greater than 2. Okay, so whenever the number is greater than 2, the value of the function will now be 2x minus 3. F of x is equal to 2x minus 3. So RHL at x is equal to 2 is limit x tends to 2 plus f of x, which is limit x tends to 2 plus f of x in this case is 2x minus 3. Okay, so this is equal to limit, as we always do, x is equal to 2 plus h as h tends to 0. So we will be writing x tends to 2 plus as now h tends to 0, and we will replace x by 2 plus h. So it is 2 into 2 plus h minus 3. In this case, you will substitute h is equal to 0 and you will be getting 2 into 2 minus 3. So this is 2 into 2 minus 3, which is 4 minus 3, which is equal to 1. Okay, therefore the right hand limit is equal to 1. Okay, so what do we find? The left hand limit and the right hand limit do not coincide. These do not coincide, or they are not equal. Okay, now further, what can you say about the value of the function at the point x is equal to 2? When x is equal to 2, okay, what happens to f of x? it will take the form 2x plus 3, and so when x is equal to 2, the value of the function will be 2 into 2 plus 3, which is 7, and you can see that it coincides with the left hand limit, but it is not equal to the right hand limit. Okay, so this also we should be showing in the problem. Okay, at x is equal to 2, f of x is equal to 2 into 2 plus 3, which is equal to 4 plus 3. That is, f of 2 is equal to 4 plus 3. Again, you can see that this is 7. So, f of 2 is equal to 7. This value coincides with the LHL, and it is not equal to the RHL. Thus, we can clearly say that LHL and RHL are not equal, and f of 2 coincides with the LHL and it does not coincide, and so it does not coincide with the RHL. Therefore, the function is discontinuous at the point x is equal to 2. Okay. Therefore, the function is discontinuous at x is equal to 2. Now, let's have a table. Continuous, discontinuous. Okay. Values of x. For x less than 2, the function is continuous. For x equal to 2, the function is discontinuous. For x greater than 2, the function is again continuous.